In this fifth episode of the AI Slop podcast, Lara Vandercaster and Eric Stalewaters talk about the effect of the initial configuration of weights on the training and function of artificial neural networks. The authors of the paper found that successful training often results in minimal deviations from the initial configuration, suggesting that efficient optimization methods like stochastic gradient descent primarily fine-tune the initial weight parameters.
Hello, I am Lara Vandercaster,
And I am Eric Stalewaters.
and this is the AI Slop podcast.
Hey everyone, today we're diving into the fascinating world of artificial neural networks.
That's right. We often think of neural networks as these incredibly flexible learners exploring a massive landscape of possibilities.
But this research might make you question if they're really exploring the whole landscape or just a tiny corner of it.
Okay, let's unpack this. We're diving into a research paper titled Effect of the Initial Configuration of Weights on the Training and Function of Artificial Neural Networks.
Don't worry, I'll make sure you understand the big picture, even if it's a little technical.
Basically, it's about how the starting point of a neural network can influence what it learns and how well it learns it. It's kind of like
Imagine a giant, super complex landscape.
it's filled with valleys of different depths.
Those valleys represent different solutions to a problem, and the lower the valley, the better the solution.
Now, picture a neural network as a tiny explorer trying to find the lowest point in this landscape.
Exactly. And here's the cool part. This research suggests that those little explorers might be more limited than we think. Here's where it gets really interesting.
The researchers basically marked the initial random weights of a network. Think of it like putting a message in a bottle.
What they found is that even after extensive training, that mark was still visible.
The network's weights didn't move much from their initial random positions, even though they went through all that training.
Wow, that's wild. So even though we think of these networks as super adaptable, they actually get stuck in their initial ways.
In a way, yes.
It's almost like they have a starting point bias.
They're drawn to the area where they first appear on that landscape, even if there are better solutions elsewhere.
And it gets even more complex when you consider the size of the network.
It's like the difference between sending out a few explorers versus a whole expedition team.
That's a great way to put it.
With small networks, it's like you're sending out just a handful of explorers, and they struggle to find good solutions, even after a long time.
They're basically lost in the wilderness.
But with large networks, it's like a massive expedition team.
They've got a much higher chance of starting near a good solution, and they have the resources to refine it, make it even better.
It's like they're more likely to stumble upon a good path right from the start.
And then there's this weird middle ground, mid-sized networks.
They can be very unpredictable.
It's like they set off with confidence, and you think, okay, they've got this.
But then, bam, they hit a wall.
Their performance can plummet unexpectedly, as if they've wandered into a dead end on that solution landscape. And this is where the concept of work comes into play.
Precisely. If you think of weights as the strength of connections between different parts of the network, changing those weights is like adjusting the flow of information.
So are you saying that bigger networks often find solutions with less work?
Often, yes. Since they're starting closer to a good solution, each individual weight doesn't have to adjust as much.
That makes sense. But this whole starting point bias thing is pretty mind-blowing.
Exactly. We tend to think of them as endlessly adaptable, able to start anywhere and find the best solutions.
So if the starting point is so crucial, does that mean we're doing something wrong? Are we just throwing these networks out there randomly and hoping for the best?
That's the big question this research raises. It suggests we could be smarter about how we design and initialize neural networks.
Kind of like giving them a head start.
Exactly. It's a really exciting area for future research.
And it seems like understanding this starting point bias is even more important as we build bigger and more complex models.
Absolutely. The larger and more complex the network, the more important that initial configuration becomes.
Okay, this is blowing my mind. So what you're saying is that with these massive neural networks, the initial random state is almost like destiny.
Yeah, it's not quite that dramatic. But there is a certain inevitability to it.
Wow. It really makes you appreciate the power of a little bit of randomness, but also the potential for harnessing that randomness in smarter ways.
Couldn't have said it better myself.
So for everyone listening, what's the key takeaway here? Why should they care about this whole starting point bias thing?
Because it highlights a fundamental truth about neural networks and really about learning in general.
That's true for our little neural network explorers, and for us humans, too.
It's true. Just like we humans can benefit from mentors and strategic planning, maybe we can find ways to guide neural networks toward better starting points and optimize their learning environments.
So we're not just along for the ride watching these networks learn. You're saying we could actually be architects designing better starting points for them.
Exactly. Who knows what incredible solutions they could uncover with a little help? It's like giving them a compass and a map before they start exploring.
That's a game changer. Okay, if there's one thing I want our listeners to take away from this deep dive, it's this. Don't underestimate the power of a good starting point. It's true for neural networks, and it's true for us too.
It really makes you think. What if we could design the perfect starting point for a neural network? What would that even look like? It's a question researchers are grappling with right now, and it could change the future of AI.
It's like we're on the verge of unlocking a whole new level of potential in these networks.
Absolutely. And it highlights the incredible synergy between human ingenuity and artificial intelligence. We have the potential to guide these powerful tools towards solving some of the world's most complex problems.
This has been an incredible deep dive. We've explored how even the most advanced AI systems are influenced by something as seemingly simple as their starting point. It's a powerful reminder that in the world of technology and in life, where you begin can have a profound impact on where you end up.
And who knows, maybe someday we'll be able to design AI systems that can not only learn, but also understand and harness the power of a good starting point, just like we do.
Now that's a thought to ponder. Thanks for joining us on this incredible journey into the heart of artificial neural networks. Until next time, keep those brain cells firing and happy exploring.
Pass that joint, Daddy.